Hello dear students, in section 4 I'm going to talk about sum and difference identities. We have some rules here. In example 2 we are going to work with it, but for example 1 we can memorize this one. It will make our work easier. If you don't memorize, I will tell you how to do it by a calculator. For example, if you know sine 0 equals to 0 and cosine 0 equals to 1 and tan 0 equals to 0 and sine 30 equals to 1 over 2, and it is like that. If you memorize them, it will be good. Let's proceed to example 1, evaluating expressions with sum and difference identities. In example 1, we have sine 75. We can do it by calculator equals to 0.96. So you have to evaluate these branches. Which one of them equals to 0.96? It is our right answer. So if you do branch A by a calculator, also equals to 0.96. So we can say branch A is our right answer. For the second example, we have cosine negative pi over 12. Be aware that pi in cosine or trigonometric functions is 180. So you have to calculate it as 180. So it will be cosine of negative 180 divided by 12. Do it by a calculator, you will get 0.96 as well. So also branch A here is our right answer. For check it out the examples, we have tan 150, which is equals to negative 0.57. So we are going to calculate them. Here we have negative inside square root, so it is undefined, it is wrong. And if you do it by a calculator, also equals to negative 0.57. So this is our right answer. Here for sine negative 11 pi over 12, we are going to do it by a calculator. How? We have sine negative 11 multiplied by 180. We are going to calculate pi as 180, so over 12. Do it by a calculator, immediately equal to negative 0.25. So if we calculate this one, that one is also equals to negative 0.25. But be aware, do not immediately choose this one. Calculate this one as well, because I just changed their places. So that one is also equals to negative 0.25. You have to look at the branches. You have to evaluate this one for yourself, or here you have to evaluate these and that one. You have to evaluate all of them. You have to be sure which one of them is the right answer. So if A and B are the same, so we have branch C, which is equal both A and B. For example 2, let's come back to our table. For example 2, let's come back to our table. We have difference identities. For example, we have sine A minus B. So the rule of sine is sine A cosine B minus cosine A sine B. You have to memorize these rules. So we have sine A plus B equals to sine A cosine B plus cosine A sine B. But for cosine is different. If we have minus, that one will be plus. It will be cosine A cosine B sine A plus sine A sine B. For plus, it will be negative, so they are the same. For tan, if it is negative, the numerator will be negative and the denominator will be positive. Here, if we have positive, the numerator will be positive and denominator will be negative. Let's solve exercises. Proving identities with sum and difference identities. Which one is equivalent with cosine x negative pi? So if you remember the rule of cosine, we have cosine A minus B. It will be cosine A multiplied by cosine B. We have minus, it will be plus sine A multiplied by sine B. So here for cosine x minus pi equals to cosine A, which is x, cosine x multiplied by cosine pi, we are not going to write negative pi because this negative is for the rule, plus sine x multiplied by sine pi. Here for cosine x and sine x, we cannot evaluate them because it is variable. But for cosine pi and for sine pi, we can evaluate them by a calculator. Cosine pi, so we are going to evaluate it by a calculator. It will be cosine 180 equals to -1. And if you evaluate sine pi by a calculator, sine 180 equals to 0. So -1 multiplied by cosine x, it will be negative cosine x. And 0 multiplied by sine x or anything, it will be 0. So that one will be 0. Negative cosine x is remaining. So negative cosine x is our right answer. Here we have again cosine. It will be cosine x multiplied by cosine pi over 2. We have plus, so it will be minus sine a, which is x, multiplied by sine pi over 2. As you know, we cannot do anything with cosine x and sine x, but we can evaluate cosine pi over 2 and sine pi over 2. Cosine pi over 2, so you can evaluate it by cosine 180 divided by 2. It will be cosine pi over 2, it will be 1, 0, and sine pi over 2, it will be 1. So 0 multiplied by anything, it will cancel, and 1 multiplied by negative sine x equals to negative sine x. So branch A is our right answer. Moving for the exercises, we have exercise 2, cosine 105 in a calculator equals to negative 0.25. So when you do it by a calculator, do these branches by a calculator, that one equals to negative 0.25. So branch A is our right answer. And for the rest examples are the same. You can do it by a calculator. So we are not going to waste time on these examples. We are going to move to the example 6. For example number 6, we have which one is equivalent with sine pi over 2 plus x. For the rule of sine, we have sine a plus b equals to sine a multiplied by cosine b plus cosine a multiplied by sine b. So we have sine pi over 2 plus x, which is sine pi over 2 multiplied by cosine x plus cosine pi over 2 multiplied by sine x. You know that we cannot do anything with sine x and cosine x, but we can evaluate sine pi over 2 and cosine pi over 2. Sine pi over 2 equals to 1, and cosine pi over 2 equals to 0. So 0 multiplied by anything, it will be 0. So 1 multiplied by cosine x is also equals to cosine x. So branch C is our right answer. For exercise number 7, we have tan pi plus x. We have what? For the rule of tan, we have tan a plus b. You have to memorize these rules in the table. It equals to tan a plus tan b over 1 minus tan a multiplied by tan b. Just use this rule. We have tan pi plus x equals to tan pi plus tan x over 1 minus tan pi multiplied by tan x. By using a calculator, tan pi equals to 0. So it means here tan pi also equals to 0. 0 multiplied by anything, it will be 0. So 1 minus 0 is also 1 here. And tan 0 plus tan x, we have just tan x. So tan x over 1 is tan x itself, which is branch A is true. This is for number 7. For number 8, we are going to immediately prove it. We have cosine 3 pi over 2 minus x. It will be cosine 3 pi over 2 multiplied by cosine x. We have minus, so it will be plus sine 3 pi over 2 multiplied by sine x. According to our calculator, cosine 3 pi over 2 equals to 0, and sine 3 pi over 2 equals to negative 1. So 0 multiplied by cosine x is 0. It will cancel. And negative 1 multiplied by sine x, it will be negative sine x. So for exercise number 8, branch D is true.